Welcome. So today I'm going to present the wireless network technologies assignment 2. I chose two questions. The one is wireless LAN security standards and relevant theories. The second one is important features of modern wireless technologies. Yeah, moving forward. So in earlier system, the security of our wireless LAN is very less. That means it used WEP, wired equivalent privacy. It established in 1997. It used weak RC4. That means it's very weak, right? The modern laptops can crack this encryption within a second. So in the earlier 1997, so it was introduced, but it's not security as our modern system. And then WPA was introduced. That means Wi-Fi protected access. Uh, it's an emergency bridge. That means it established to resolve the problem in the WEP. And it used the TKIP protocol. That means temporal key integrity protocol. Uh, it fixed the WEP problem, but that also is not a good security for the wireless technologies. So in that period of the time, it can be unbreakable, but after some network technologies increased, it was breakable in the early 2000s. So the next standards was introduced in 2004. That means WPA2. This is the industry standard protocol. It use advanced encryption standard. That means the data will be encrypted, and then we can protect the data with the decryption mechanism. But it's also vulnerable to handshake attacks. It will protect the data, but it will never uh, prevent from some handshake attack like crack. Uh, sorry. Yeah, but compared to the previous WPA, uh, WPA2 is more secure, right? And then we introduced, I mean, not we, the WPA3 introduced in 2018. It used simultaneous authentication of equals. It means we can easily, we can protect the systems, technologies against the offline password guessings. So more of our attacks are used by guessing the password with some combinations of keys, right? So it will restricted that one, and then it will also provides encryptions in the public network also. In the previous times we used encryption for the private network, but that is not secured. But also we can use these options in the public also. It will protect our network. Okay. So moving forward, so there are also some theoretical foundations about security. So encryption, that earlier I told, like it will encrypt the data. That means we can add some random text or random keys to some actual data that we call as ciphertext. It will the normal people or normal human brain doesn't understand the uh, encrypted words. It will um, only readable when it's decrypted with a specific decryption algorithm established by the encrypted people. So we can encrypt and then we can decrypt with some specific algorithms, right? Yeah. If I encrypt some data with some specific set of rules, I can only decrypt that. Okay, so that means the encryption and decryption will work uh, with some specific rules, right? And then another one is authentications. So we can use many networks as we want, uh, but it will uh, authenticate who is using the system. So we have to identify ourselves to get access to the network. That is authentication, the encryptions for the data and the authentication for the user. And then we have CIA triad, that means confidentiality and then integrity and availability. So confidentiality is the data can be confident. Only authorized users can read the data. Not everyone can read the data. Integrity is we have to make sure the data is not altered or not tampered with any kind of signals. Okay, right. And then available. The network is reliable and accessible. When the network needed, the network has to be available and then accessible. Sorry. Yeah. So next one is Bluetooth. So Bluetooth, I think everyone is now familiar with Bluetooth. So everyone has a mobile, and each and every mobiles we have Bluetooth to connect some peripheral devices. That means wireless earbuds or wireless headphones, or we can connect some mouse, or we can connect some keyboard with Bluetooth. Earlier 2010 or something, I used to share the some small image files to some mobiles. Okay, so I hope everyone is familiar with Bluetooth. So it uses 2.4 gigahertz ISM bands. So it's not suitable for the wide range network. We can use it in the small area. That means it's a pan personal area network. It's very efficient in the short range. I mean, we can use the Bluetooth only in the short range, so the energy consumption is less. Yeah, it's uses for audio streaming and then peripheral devices that earlier mentioned, and then wearable health trackers. Consider when we consider about audio streaming, the earliest stage of Bluetooth, there we can some latency or something. I think now with the Bluetooth 5.0, I think, yeah, 5.0, the latency is reduced, and then we can easily stream the audio. And then it's very low data rate, and then uh, compared to the Wi-Fi, it's very limited range. So we can only use within some, uh, I think it's like 10 meters distance or something, inside within the 10 meters. Right. And then second one is Zigbee. Most of us are familiar when we are if you are familiar with IoT, we can't avoid the Zigbee. It will widely used in the IoT, and then it will use a mesh networking. That means mesh topology. Each and every IoT devices can send and transmit the signal, right? So each and every devices act as a node and then receiver. So it will how many devices when we are connecting with Zigbee, it will expand the network as a massive route with the without the massive router. And then it is very efficient because most of the time IoT signals needs to be sleepy. That means we have to send the signal only when it's needed. uh, Not like other technologies, it's the network is not open for every single moment. So when it's necessary, we can send the data. Okay, yeah, like temperatures or something. And then we can it's I like I said, it's efficiency, so it can run in a small single cell battery also. And then another important topic is Wi-Fi. We heard about Wi-Fi. We are using Wi-Fi every time, but Wi-Fi is something different. That means it uses the light spectrum instead of radio waves. In the Wi-Fi and Bluetooth also earlier, I used to know we used uh, I mean, infrared waves to transmit some files in the mobile phones or some small devices. But then we move to the Bluetooth, and then we are using the Wi-Fi also. So instead of radio waves, we are now using the light fidelity. I mean, we are using the light spectrums for transmit the data. So it's when we involving the light, already the speeds uh, has to be increased because it will light travels very fast. So it has the very speed, and then it has the security also. So light cannot penetrate walls. That means physically it's very safe from the outside attack, but also uh, it's a negative for the negative for the Li-Fi also, because each and every time um, the network has to be line of sights. I mean, if I am going to use two devices, for example, so this device and this device, the both devices are need to be uh, in the uh, in the sides. So if I put something in between the devices, it won't work, right? Yeah. So the advantages and the negativity also, I mean disadvantage also, the light cannot penetrate walls. Yeah. So we use 2G and 3G, 4G, but now we have 5G for the networking. Most of our modern area in Sri Lanka also we have 5G technologies in the mobiles. Yeah, right. But also beyond the mobile phones, we are using the 5G in the MMTC. That means massive machine type communication. So when we think about 5G, we only think about the mobile phones. But beyond the mobile phones also, we are using the 5G also. And then it has very ultra low latency. That means the data transfer very fast, and there is no lack of data transfer. It will efficient for crucial things like surgical, and then self-driving cars like Tesla or something, right? And then it the network is very dense. That means with some square of kilometer, we can use millions of devices at the same time. And then it can act as a connective tissue for some big cities. So before I am going to conclusion, but I would like to mention um, something in the laws of computing. There is a law called Gilder's law. That means one of the interesting law in the law of computing. Uh, Whenever the computing power increases, the total bandwidth of communication system grow at least 3 times faster. I mean, if we are the computing power is increasing day by day, so also the total bandwidth of communication system also grow 3 times faster than the computing power. Now we are moving into some quantum computing also. So consider if it's we are going so fast to the computing power into the quantum computing, the network bandwidth also will be increased, and then our communication also will be increased, right? Yeah. And then conclusion, right? So security. So like I said earlier, we have used some um, uh, basic security system in the WEP, and then we have more powerful security in the WPA3. And then there is no one size fits all wireless technology. Means there is no limitation for the technology. We can expand and uh, improve our technology day by day. And then uh, if a technology have power, and then range, and then also speed, it's a trade-off situation. In one technology we can increase the power, and but we can lag with this range. Also we can lag with power. So but in some technologies we can increase the range and speed, and then we can't increase the power. So this is a trade-off situations. The one can increase and one can decrease, but we have to use that network properly when is needed. If I want power, not the range, we can use the power one, right? So there's some trade-off situations also. And then in the future we can connect the connectivity become invisible, and then integrated, and then ubiquitous. That means it is increasing day by day, and then it can be massive in the future. Thank you.